Okay, so with the programming that you've already done, I'm sure that you've had to repeat yourself. And what I mean that by that is I'm sure that you've had to write some code and then copy it and paste it because it was literally the exact same or almost the exact same. Well, and you probably didn't like that because what if you misspelled something somewhere else and then you needed to fix it? Well, now you have two places or three places or four places that you have to go in and fix that. And that's not something that we want to be doing. So functions allow you to encapsulate logic into its own entity that you can call over and over again. And so I'm going to talk a little bit about why we should create functions at the end of this lesson, but I'm going to go through and just talk about them and how we can create them. But first I wanted to say that functions aren't new. This isn't a new concept. You've been doing this already. For example, you've used the int function, which takes a string representation of a number and returns its numerical value, its integer value. So we've already seen that. There's also raw input, which takes a prompt, like when was the last time you had spam? So it takes that and it returns, and then once they enter something on the keyboard and press enter, it returns their answer. So we've already seen that. You've already been able to use your own functions. But where do they come from? Why do we have functions? And just like most things in programming, if not all things, they have some sort of mathematic background or history. And so I'm going to take us back to the days of algebra, which I'm sure were your favorite times of your life. So in algebra, you probably remember our favorite function f of x. And what f of x did is when you plugged in numbers, and this was the body 2x plus 3, whatever. It was always different. And you had to solve for x or, things like that. So, but when we replace x with a value, then it returned a number. And so for, f of 0, it would be 3. And then for f of 1, it would be 5. And for f of 2, you already know, it would be 7. And so this graphs a line. And for all of these functions, they do something interesting. Some are parabolas or some are lines, or if you've got multiple variables, then they created ovals or circles. And so there's really cool things that you can do. But usually when you were doing this, if you were like me, you were thinking, well, when am I ever going to use this? When do I ever create functions? And hopefully you have used them before elsewhere. But programming is a really good opportunity to remember functions and see their actual use. And that's what we're going to do today. So I'm going to create a function, and then I'm going to go through the pieces and how you can kind of create your own. So first, we've got this def keyword, and the function that I'm going to create is called special divide. And this is the divide that we learned in elementary school that returns a whole number and its remainder, and none of this decimal stuff. So in special divide, I've got two parameters. It's going to be the number and the divisor, and then I put a colon. So let me explain this really fast. So def is a keyword, and it's basically telling the Python interpreter, hey, I'm about to define a function. And so that's what this is doing. It's defining a function, and then we give it a name, and we're calling this special divide. So instead of f, like we've got up here, ours is called special divide. And then instead of x, which we had up here, we've got two things. So we could call this x and y if we wanted to be like hardcore math algebra. But we're going to call it number and divisor because we can name them whatever we want. And so then we've got this colon to indicate that this is beginning a block. So whatever is coming next needs to be indented to be inside of this block. So this is just like we did with if statements or for loops or while loops, if you've seen those already. So we just have to make sure that this part is indented. So this is the body of the function. I get to do whatever I want here. So what I'm going to do is I'm going to have the division is going to be number divided by divisor. And since this is going to be our cool elementary school division, we only want whole numbers. And so I'm going to make sure that that's all this returns. I don't want any decimals. So I'm going to use the integer function to to just cut off any decimals that we've got. Then we want the remainder, and that one is going to be number mod divisor. So then here is the other key part of a function. So in a function, you have an input, which is x, and then you have the output. So 3, 5, or 7, these are the outputs. And so we've got to define the outputs, and we do that with a return statement, which is another keyword. So we say return, and then we can return our outputs. And just like our function took multiple things, so f of x only took one thing, ours takes multiple. And just like it only returned one, ours can also return multiple. There's no reason why we can't return more than one thing from a function. So we're going to return the division and the remainder. So that's cool. That's a function. But this doesn't actually run the function. All we've done is declared it. All we've done is defined what this function is and what it does. But in order to call it, we do what we've done elsewhere. So up here, we obviously called a function. So the way that we call that is we call it by name, and then we put parentheses, and then give it the arguments. And so if we wanted to divide 9 by 3, and let's try also dividing 10 by 3, and we'll just print out the result of that. So when that runs, we get 3 with a remainder of 0. And then the second one, 10 divided by 3, is 3 with a remainder of 1. And so that's perfect. That's our elementary school divide. So that's really cool. So now you know how to create a function and how to call that same function. One thing that you need to remember is this would not work. So it's going to say, whoa, I don't know what special divide is. So if you're going to call a function, it has to be declared first. So it's the same thing with a variable. You can't use a variable before you've defined what it is. So it's important that you do that. Then the other thing that I wanted to point out is that special divide is pretty much a variable name. And it must be named with the same requirements that variables must be named. So I can put a number in it or in between it, but I cannot put a number at the beginning of it. So that's important to know. Also, I just wanted to point out, and this is something that beginner programmers and myself, when I was learning to program, I struggled with this. So if I wanted to call excuse me, this function with certain numbers, I could have them be like this, and divisor equals 3, and then instead of putting the actual numbers in here, I'm going to put 9 and divisor, and 10 and divisor. So when I call this, we get the same thing. But it's important to know that the function does not care that this was called 9 or 10 out here, and that this was called divisor. I mean, I could call this plum. Let's see. So it doesn't matter that it was divisor before and that it's plum now. It doesn't care. So the function only cares what they are inside of the function. So in this, we call this a signature. In this signature, it chose what the variable names were going to be. So then when we pass them in here, it's actually just going to copy the value that's in this variable and assign it to this variable. And it's going to do the same for all of them. And so it doesn't matter what the name is out here. This is really just a box. So it just takes the thing it takes the value out of that box and sticks it into these boxes. So that's something that some beginner programmers really struggle with, but I really want you to know right off the bat that functions get to define the names inside of their function. They don't care what they are elsewhere, with a few exceptions, which I will talk about in a future video. But ultimately, you should know that names exist inside of the function. So you might be wondering, why do we need functions? So, I mean, as I'm doing this, you may have seen that, hey, I could write a program all in line, without calling any functions. And you're right. We don't really need them. They're not so fundamental. It's not like you can do new things with functions that you couldn't do just writing it all out. But the problem is, and you've hopefully already seen this, and you're just jumping for joy because now you have something that you don't have to repeat yourself. So in this case, I wanted to do a special divide, and I just gave it 9 and a division. And I should just, yeah, I'll call that divisor again. So I just don't want to call it plum. So I was able to do this, and then I was able to do it again in one line by just giving it a different value. And I hope you see the how much that helps you. I hope you see that that can really revolutionize your programs because now you get to put the logic that needs to be repeated in a function and just call that function over and over again. So I hope it's pretty apparent, but I know that sometimes people say, "Oh, well, why do I need that?" This is really just a convenience mechanism for you when you write your programs. So this is functions. We use them all the time. Even though I said that they're not vital to your program, you could write the same program without functions. You're not going to be able to scale and write as much as if you use functions. Functions will make your life so much easier. So anytime that you find yourself doing something over again, or even any time that you've got 6 lines of code or 15 lines of code, you should probably think about putting that in a function. Because the cool thing about functions is that you get to name it. So if there's a certain part of code that's doing something, if you put that in a function, you get to give it a name. You get to say, this is what this part of the code does. This does a special divide. So anyway, these are really important. We're going to talk about it a lot more because they're super important. But this is a good intro to functions.